I kept a block. The block is moving with velocity 3 meters per second. And the platform is having velocity 3 meters per second. This is a block of mass. And this is rough. Huh? What is the mass of block? 2 kg, and the mu is 0.3. So the diagram, practical diagram, it appears like this. Huh? And the block is okay, fine. So this is the platform. The platform is moving, so one direction, and the block is moving. So it's asking now what is the direction of friction. I'll explain the question here. Huh? A block of mass m is kept on the platform.
Yeah.
The velocity of block and platform are as shown. Find the friction force acting on the block. Yeah. The platform, you don't bother that one. Platform, here how the G will act like this. The platform is kept on again smooth surface. The platform is moved along Z direction. This is a top view, this is a side view. You can do it. Take eraser, keep it on notebook. Eraser, you just strike the eraser like this, and simultaneously move the particular notebook here. And there's a platform.
Sir,
Yeah.
is it in the southwest direction, sir?
So it should be opposite to the relative velocity, no?
Yes, sir. That is southwest direction. If we take
Yeah,
north
that
as
one.
the
Yeah, that one. Okay, yeah. I'll check the with answer. So how to what is the idea of friction? The friction will always act to oppose relative motion, no? So here I'll find out the velocity of platform, velocity of block with respect to platform. V1 bar minus V2 bar. So here let me define the coordinate axis. I think this will be better. Here it may appear different, so let me assume like this. This is x and y. I defined coordinate system also. So here if you are showing, you have to show like this. This is x, this is y. How the z-axis? Z-axis will be vertically down. Z-axis will be vertically down. Is that okay? Fine. Okay, now V1 bar. V1 bar will be 3i cap. V2 bar, so this is 2, no? 2i cap. and this will be 3j cap. So 2i cap minus 3j cap. How the relative velocity V1 2 bar should be directed?
Sir,
So
minus
V1
J.
2i cap.
Sir, J cap, sir.
J cap minus of minus, no? This is okay.
sir, no, sir.
Sir, K cap, K cap.
No. Try to.
No, sir, it is J cap. Sir, it is plus 3 J cap, sir.
2 I cap. No, that's y-axis I
That
took
the
here. No? Okay, okay,
platform is moving around.
diagram. Okay, then I'll change the direction. This one a little bit. This was y-axis. Yeah, there's some correction is there. Yeah, I'll do one thing. Let me keep it here only. Again, y2. You look at the platform. Platform is moving along negative y-axis, minus 3 j cap. This will be 2 I cap plus 3 j cap. This is V12 bar. Look at this 2 I cap plus 3 j cap. How the vector should be in the first quadrant. The vector will be directed somewhere in the first quadrant. Here I'll put it V12. Opposite to V12 is what? The friction should act here. So the friction what happen? This will be negative y-axis and positive axis. So the direction of friction should be opposite to this. This is what the friction. This is what friction on the block. On the platform should be opposite to that. So how much of angle it will make? So this will be theta. So can we calculate anything theta? Tan theta should be equal to 3/2. So what is the expression for F bar? F bar should be equal to F cos theta I cap F sin theta j cap. Now what is F? F should be equal to only mu mg. F should be equal to mu mg. So mu mg cos theta I cap plus sin theta. So we know tan theta. From here, what we should find out the cos theta and sin theta. So from the triangle theta 3 2. So this will be root 13. It will come. And what is further F? F should be equal to mu n mu mg. So like this, we'll get the expression for the friction, that one. So this should be equal to value is how much? Mu is 2. I'll minimize it. Mu is 0.3 into 2 into 10. 6 Newton. So this will be 6. Cos theta will be 2/13. 2/√13 I cap. 6 into sin theta will be 3/√13 j cap. Like this, we'll get the friction. So what is the idea of this? The friction will always act to oppose relative motion between the surfaces. That's one basic idea on which we are moving.
Sir, shouldn't the friction be negative, sir? Minus and minus. This is in the third quadrant, right?
That's minus of. Okay, then this one. Yeah, on the this is on the block, no? On the block, it should be like this. Huh? Then on the platform, what it will be? Yeah. On the platform, you have to make it positive. On the block, it will be like this. Huh? So I'll write this one on the block. The question asked on the block. No? If they ask you platform, then you have to make it positive. On the platform, it should be opposite of this. So the friction will always act to oppose relative motion, not to oppose the motion. So here you should not show the friction direction opposite to velocity, opposite to relative velocity.